Excellent. Well, yeah, we'll get started. Perfect. All right, so welcome everyone. Let me make sure. Nice. So we got quite a few people in our live viewer list here. So as I've done during the past couple of sessions, I wish everybody good morning, good afternoon, or good day, since we are assuming you're tuning in from pretty much across the globe. Thank you very much for making the time today to join us here during our last live event of ASBS 2020, and really not least because we have a fantastic guest, and I'm really excited that she was able to make the time here today. Just as a quick reminder, all of the live sessions are recorded, and all of the previous recordings, including all of our other nearly 40 speakers that have joined us this year can be found on our YouTube channel. That is in the link that I've put into the chat box. So please feel free to go there. And also, I do want to really advertise for the video that Dr. Erika Wagner, who's joining us here today, pre-recorded. It's really fantastic. If you haven't had a chance to watch it, don't watch it now, but watch it after this session. As I mentioned, this one also will be recorded, and you can rewatch it later on as well. If you have, and you're more than encouraged to ask questions during this session, if you have any, please post them in the Q&A box, not in the chat box, so I don't miss them, and we will get to them and answer all of them. So feel free to ask anything and everything, and I'm sure Erika will do her best to answer it. So with that, it is my great pleasure to introduce to you Dr. Erika Wagner, who is the Payload Sales Director at Blue Origin. Most of you, I'm assuming, are familiar with Blue Origin, who is a developer of vehicles and technologies to enable human space transportation. That's their main goal. And we'll go into much more detail once I turn it over. But I wanted to give you a little bit of background to Erika. So Dr. Wagner received her bachelor's in biomedical engineering from Vanderbilt University. That was followed by a master's in aeronautics and astronautics from MIT and a PhD in bioastronautics from Harvard and MIT Division of Health Sciences and Technology. Her research spanned both human and mammalian adaptation to microgravity, partial gravity, and centrifugation. She's also an alumna of the International Space University and an associate fellow of the American Institute of Aeronautics and Astronautics. Prior to joining Blue Origin, Dr. Wagner worked for the X Prize Foundation, which is, holds public competitions intended to encourage technological development to benefit humanity. There, she was the Senior Director of Exploration Prize Development and founding Executive Director for the X Prize Lab at MIT. Previously, she served at MIT as Science Director and Executive Director for the Mars Gravity Biosatellite Program, a multi-university spacecraft development initiative to investigate the physiological effects of reduced gravity. Erika has previously served as a member of the Commercial Spaceflight Federation's Suborbital Applications Research Group, the board of the American Society of Gravitational Space Research, and NASA's Planetary Protection Independent Review Board. I think we are all more than honored that you can join us today, and admittedly, I'm very jealous of all your previous experiences, which we're sure by itself could fill an entire day. But today, we're really grateful that you're joining us to tell us more about Blue Origin and the suborbital flight program, but also where the future is taking us. So please all welcome with me, Dr. Erika Wagner.
Thank you so much, Chris. It's so nice to be here and to be among friends and colleagues who are also thinking about these challenges and opportunities in the life sciences as the frontier of space continues to open. I just wanted to take about 10 minutes to do a mini version of the talk that's online and just sort of introduce the topics so that when Chris and I are talking, we're baselined here. New Shepard is the first of a series of vehicles for Blue Origin, and we were really developed with a vision of millions of people living and working in space for the benefit of Earth. And you'll hear us talk a lot about this philosophy of gradatum feroster, or step by step ferociously, that is moving us from the things that we can do today to the visions that we have for tomorrow. So New Shepard is our suborbital launch vehicle. It's the one that's flying right now. On the right of this chart, you see New Glenn, which is our orbital launch vehicle in development and pieces in construction down at Cape Canaveral in Florida. We're also developing lunar lander systems and a whole lot of other things that are really exciting. But as we talk about New Shepard and what's going on today and the opportunities for researchers, I wanted to sort of anchor that in thinking about what is suborbital flight. These are launches that are going out of our privately owned and operated launch range in Western Texas. New Shepard is a single engine vehicle that launches almost straight up in a parabolic trajectory. So we're gonna go up for about 2.5 minutes to about 70 kilometers, separate the capsule from the booster. Not like that, that's an escape mission that you're seeing there, but just a gentle separation of the capsule from the booster. Both capsule and booster go up over the Kármán line, that edge of space, and then come back down for a soft landing. The architecture is really interesting because it allows you to get about 3 minutes of contiguous microgravity. So for researchers, this is a lot more like one giant parabola. I really think of it more in family with parabolic flights than I do with, thinking of it like a little bit of space station. Because what it's giving us is about an order of magnitude longer and 2 orders of magnitude cleaner microgravity than we can get on airplanes. Now, when we look at the opportunities that this kind of a flight profile gives us for studying in the life sciences, some of our researchers really are looking for that altitude. We're flying in this region that they call the ignorosphere, which is between 60 and 100 kilometers. It's too high for a balloon, too low for a satellite. But most of the life scientists that we're working with are putting payloads in our cabin, and they're really taking advantage of that microgravity period as we go up over the top of this trajectory. In a human-intended configuration, and we're gearing up for our first human flights pretty soon here, we will have 6 astronauts arrayed in a circle in the cabin. Each of those seats, we like to joke, is both a window seat and an aisle seat. So some of the biggest windows ever flown in spaceflight history. And so we'll talk a little bit at the end of the talk about where that intersection is between humans and researchers, because so many people are really thinking of this as a vehicle for tourism. But what we've seen is that the opportunities for research are vast. We've just finished our 10th payload flight, flown over 100 payloads, many of those through NASA and their Flight Opportunities Program, federally funded research, but also increasingly people coming and just, buying this like they buy time on a beam on the ground, a radiation beam on the ground, or another commercial procurement. We've had researchers from 7 different countries working with us, and look forward to thinking about this as a new way of doing spaceflight research. It's not the propose and wait necessarily, but more just the procure and fly, which really changes the way that we can think about who has access and how. So in that payload configuration, we have 6 stacks of payloads that we can outfit into the vehicle. Each of those stacks is capable of carrying 6 lockers, about equivalent to a mid-deck locker in the space shuttle or space station. And we can do payloads that are full stacks, multiple stacks, or payloads that are really small in the size of small CubeSats within a stack. So really a wide range of ways of accommodating researchers' needs. If you look at the kinds of payloads that have flown with us, the majority, and this is due, I think, mostly to the way that NASA has been funding, have been in the physical sciences. Lots of interesting work being done, particularly in fluid management, fluid handling, 2-phase flows. But if you look at the kinds of things that fit into 3 minutes, you open the doors a lot wider. So combustion certainly is something on those rapid timelines, solid, liquid, and gaseous combustion. Material science, things like low temperature solidification, the seeding of crystals in small molecule growth. And then a lot of work being done in technology maturation. So NASA's technology readiness level scale takes things from TRL 3 or 4, that means they're working on your benchtop on the ground, to TRL 6 or 7, meaning that we've demonstrated subsystems or full systems in a relevant environment of spaceflight. So we're seeing a lot of folks who are using this as a way of maturing their technologies and doing risk reduction for platforms like space station. In the life sciences itself, really interesting opportunity here for looking at acute responses to microgravity and to G transitions. If you're going to space station, you might wait a couple of days actually from launch till the experiment is unpacked and you're in there actually doing science. So this is really looking at how systems respond initially to that microgravity environment. For some systems, this is enough time to look at a relevant change. So lung deposition, vestibular reactions. For other systems, we're really looking more at how do we develop the technologies that allow us to do more in-depth studies on longer duration platforms. So we've flown a number of biological imaging systems, medical tools, and the like. So as I think about the ways that we do this, one of the enablers that we've introduced is standardized interfaces. We're happy to do custom, absolutely happy to work with investigators who have other ideas, but using our interfaces means that you don't have to develop your own structure, you don't have to develop your own flight computers, and that really can take things faster than ever before from the benchtop into space. So just to give you a rough idea, a single locker about the size of a small microwave, about $100,000 for flight, just to sort of help baseline that there. I just wanted to talk about a couple of emerging capabilities that are coming for us down the pipeline. One is our partial G mission. And this is an interesting one that comes out of research that I was really passionate about and focused on in my graduate studies, which is what happens in those G levels between 0 and 1. We know that a lot of systems are nonlinear in their responses to G, but we don't really know where threshold behaviors might lie. So there's a great opportunity here, probably 2023, for the first flight of this system, taking the capsule, rotating it with the reaction control systems. So it basically serves as a giant centrifuge. About 1.5 meters radius, 11 RPMs gives us lunar gravity inside the payloads. And we can start to look at things like G thresholds, the ways in which combustion is impacted by diffusion limited and convection limited processes, the way that you might handle dust on the lunar surface. So really excited about this as an emerging capability that's really not offered anywhere else in the world. And because this is a life sciences audience, I definitely wanted to hit on human-tended payloads. I don't know about you, I'm excited about going someday. This is something where I would love to have my own investigations on the vehicle and be able to start to look at what happens to a much more diverse population of human responses. Or to take experienced investigators and to extend the laboratory up to space. Normally with an astronaut on the space station, we might get 10 to 20 hours of training rather than 10 to 20 years of experience that you have in your own laboratory. So I think that what we've seen is for a lot of these things, either training someone else to do the experiment or having to fully automate it is actually much more expensive and much more risky than sending the investigator to do the higher quality science. So lots of cool opportunities opening up there to look at the hundreds of tourists that are going to be flying, to look at the opportunities for focused biological research. Just as a framing for those who might be in the US or working with US investigators, NASA has a new program that just got introduced this spring by Administrator Jim Bridenstine called SUB-C, or Suborbital Crew. And this is going to be opening up the doors for NASA astronauts to train on these vehicles, but also civil service researchers to be flying. And I think that what we'll see is once NASA has sort of put its seal of approval on these vehicles as appropriate for research and safe to fly for researchers, that we'll see that a lot of other space agencies will come and adopt this and collaborate. So Australian Space Agency, I'm looking at you. We'd love to start flying your folks as well. One last mention, and I think it's interesting to think about the ways in which commercial spaceflight is changing the way we think about access to spaceflight. This is one of my favorite projects that's coming down the pipeline, working with a group called Uplift Aerospace. They have artists that are going to be painting world-class art on our rocket, flying it to space, bringing it back, excuse me, and then offering it up for collectors to have a piece of art that's been shaped by the space environment. So I think that when we sort of look at that in totality, what we see is we've got a really wide range of new things that can come to space, new ways that people can introduce their research into the space environment, capabilities that, compared to what we can get on airplanes today, are giving us cleaner microgravity, longer microgravity, and more flexible environments for conducting research than ever before. So this is our one of our research crews down in West Texas. They woke up that morning, came down to the launch site. Their payloads got put on the vehicle. It flew to space. It flew back, and this afternoon they're standing there next to the vehicle that just came back from space. And we'd love to have you join us. So with that, Chris, let me stop talking at the audience and have a bit more of a conversation with you.
No, that's really fantastic. Thank you. Thanks for putting this together. I think it gives a really good, initial overview. And I invite anybody who's listening in live to please, don't hesitate and ask any questions, and we will pull them up as they come in. I think maybe to get this started, if you don't mind, if we can talk a little bit about, kind of how does it, from kind of start of a researcher approaching you or making first contact, kind of what is the timeline, but also what are the milestones or steps that somebody may want to expect?
Yeah, so that's a great question. I would say that people come to us in two different modes. Some come to us because they have a very specific proposal opportunity they're responding to. Their space agency has made a call, or their science agency has made a call, and they're coming and saying, hey, I'm writing this proposal. I need to know what's the budget line for putting the spaceflight there. Other folks come to us because they have a science need and they're trying to figure out if this is the right platform. So in both cases, what we're going to do is we're going to start with our payload users guide. This is a document you can just request by email, payloads@blueorigin.com, or on our website. And it tells you all the details of the sort of technology, the interfaces, the operations, the environments of the vehicle. And so we'll get you all those details in place. And then we'll have a conversation about the scope of work that you need to work with us. So do you need any special interfaces, any special operations at the launch site? And from there, it's actually a pretty commercially friendly kind of process. We'll provide a bid letter that can go into your proposal or work with your company or your university, and we'll sign a contract. From contract to flight, we have been really working to keep this a very streamlined process. So we're talking about orders of weeks to months rather than months to years, like some folks may be used to with Space Station. So typically, let's say about 6 months is a good process length for us, where you'll come in, you'll do 3 reviews that get you ready for flight. The first is a lot like a preliminary design review for my engineers out there. We'll be asking you what you're trying to accomplish. Give us the basic, sort of sketch level design. What do you understand about your operations? What are your requirements? The second review, which is typically around 3 months before flight or so, is a critical design review. And we'll be asking a lot more questions about safety. Show us your schematics, show us your prototypes, help us understand what the hazards are in your payload and how you've mitigated them. And then the final review is flight readiness. It's about L-1 month, about 1 month before flight. And in that case, you'll be coming and you'll show us that you're running your payload on the benchtop with our simulator plugged in, that it's running the way you expect it to, that we understand everything you're going to need when you come to West Texas in terms of your benchtop operations, and that we're ready to go. Because before we know it, you'll be putting hardware onto FedEx or DHL to come our way. So I think that's sort of the process. We'll try to understand the science and the technology needs. We'll try to make sure that you're going to be safe to fly on our vehicle, and we'll get you down to Texas.
Sorry, my mouse didn't want to react. No, that's perfect. Actually, like maybe to really continue on that, in terms of safety, and kind of guidelines, specifically in terms of biological samples, and maybe somewhat hazardous if people have something that they would love to fly that is somewhat hazardous. What are kind of the guidelines, and maybe especially the difference to what I'm assuming is a big difference to manned missions, etc.? Is there something that's important?
Yeah. So let's start with what's easy. So BL1 or BSL1, the kinds of things that you can operate with on a benchtop in your laboratory in an open environment, that stuff's easy for us to work with. And that tends to be most of what we're flying. We have flown some BSL2 samples, either human tissues or minimally hazardous organisms. That requires some more back and forth, making sure that we have appropriate levels of containment on the payload itself. So if there is a bad day on the rocket, that we know that that's going to be safe for the ground crews that are interacting with it. But also thinking about how do we deal with your end-to-end experience. Typically, folks who are dealing with biological organisms aren't going to deal with them in our facilities in West Texas. We have a pretty simple laboratory, but they'll be partnered with one of the local universities. The University of Texas at El Paso has a great core bio facility that a number of our researchers have partnered with, and that gives you everything that you would need at your home laboratory, incubators and counters and sequencers and the like, but also an appropriate biological facility to be working with on the ground. So just a drive up the road in El Paso.
Is going forward, I think that's also maybe something interesting, depending on, how much further kind of this program versus, the New Glenn, et cetera, what the vision is there a thought of maybe adding a biological, like facility in a lab space that's more dedicated, or is this more, well, we know that El Paso has all these capabilities and it's, there's no need to interfere, like we don't need to reinvent the wheel, of course, but just curious.
Yeah, no, it's a great question. We've looked at this a few times in a few different ways. A good, solid biosafety facility is expensive. If we look at it through that lens. And so far we have not had enough demand to justify that kind of an investment. But certainly if we had customers that were coming with a series of flights and really wanted to do it, or in the case of a space agency that wanted to put either a temporary or a permanent facility at our site to accommodate these things, definitely something we're open to. So.
Mm-hmm. Mm-hmm. And maybe a little bit more, if we talk a little bit more details on like power and I guess gases are probably not available, but there's certainly onboard power available, and kind of if we could maybe visit that a little bit, depending on what kind of units and whether locker or like nanosat or what is
Yeah,
flown.
absolutely. So let's put that slide back up because that'll help us walk through this. So a standard single locker has 4 power channels that it gets fed through the integrated payload controller. Each of those power channels is essentially a 27-volt DC bus with 2 amps. So you can get up to 8 amps total. So let's call it it's a round number, about 200 watts of power. And that can be provided continuously throughout the duration of the mission. Other folks that need power that is higher than that, we have worked to provide multiple power inputs to lockers. We've supported batteries flying on lockers and all sorts of other creative solutions. But 200 watts is the easy, quick answer. For the double locker, the provision is the same. For the full stack, that's replacing an entire seat in the cabin. That one has quite a bit more capability there. So you're seeing 44 amps of peak current on those same DC power levels. So typically for someone who's coming in and working with one of these systems, they're going to have a DC to DC converter inside of their locker that steps them down to whatever voltages that they may need within their individual hardware. For the smaller mini payloads, these are the 2U form factor. It's a 1.1 pounds, half a kilogram of hardware. It's just going to get a simple USB cable, and these are really designed for student experiments or very small corporate payloads. We can do multiples of these, so you could have something that is 2U with 5 volts, or 2 of these together with 2 USB connectors to it, or 3 of them together. But I think that what we're trying to do there is to really support the simple electronics. These are typically a Raspberry Pi or an Arduino with a camera and a light source, some very simple pumps or the like that are allowing the smaller form factor experiments to run.
Mm-hmm. Perfect. So we have a question from Janice Staudemeyer from Space Tango, actually. And she's asking if you could, first she says, great presentation, which I want to also pass on. She's asking if you could talk a bit more about the benefit of using both suborbital and orbital flights to foster the development of the commercial marketplace in low Earth orbit, e.g. raising technology's readiness levels.
Yeah, that's a great question. Thanks, Jan. I appreciate it. I think that what we've seen is that there's really been this gap between things that are working in a lab and things that are working successfully on space station. And that gap is technological. We have technology risks that need to be burned down. It is experience level. We have research teams that have never worked in space that need to get sort of ready for the ISS platform. It's financial. They may need to get another round of investments or another level of grants and are looking for that preliminary data to justify that deeper investment. And I think what suborbital does is it fits really nicely into that gap. So we see a number of experiments that are coming, new users or new hardware or new experiment domains, where suborbital is really the natural step to prove it out. This is the proving ground. And so we'll see that suborbital experience is really what you need to either get that next round of investment or write that first paper or justify that bigger grant that allows you to take the next step, whether that is to the International Space Station or commercial platforms or the lunar surface. I think it's a natural progression.
Yeah, I would personally agree with that as well. Yes, when you so we talked a lot about like the different sciences that have been on board. Like, could you give like specifically for life sciences, like do any of them come to mind, like in terms especially like cells or microorganisms or something, just so our audience gets a good idea of what has already been done and maybe what's in the planning?
Yeah, so we've had T cells that were being flown and looking at gene expression. We've done a number of different plant studies where we were looking at either gene expression or phenotypical changes. We've had, let's see here, water fleas, zebrafish, mini jellyfish, a variety of small model organisms that we've flown. Tissue constructs, skeletal muscle contractility studies, looking at the needs for how you would support electrophysiology experiments, and then a number of experiments that really were more focused on imaging, but using a wide range of cell types to test out those platforms.
Mm-hmm. No, that's really excellent. I think it's really important to really understand that technically everything is possible as long as certain requirements, I guess, are met in terms of, as a researcher you need to ensure that your cells survive and do as they're supposed to be doing, and you provide the flight data and the power during the flight. So I think that's really important.
Chris, can I turn the tables actually and just sort of ask you to describe your experiment a little bit, because we're getting ready to fly some work together with the Mayo Clinic, and I think that your experience and what you're developing is actually really relevant here. Would you mind?
Yeah, no, I don't mind. I'm not gonna just out of because we're still in the process of actually putting it together to publish it soon, hopefully. So I'm not gonna go into too much detail what the experiment is, but we are, as Erika mentioned, flying human cells on actually 3 scheduled flights with Blue Origin, so that's going to be really exciting. And we want to be looking at kind of so that the hardware that allows us to really get a step-by-step kind of, I guess how to describe it, like a step-by-step visualization almost of what's happening during the cells, to the cells during the suborbital flight. And funny enough, as you mentioned this earlier, after Jana's question, it originally we thought, well, this is something we can on a suborbital flight. But now, as we're developing it and running through multiple iterations and all of that, all I can see is all the possibilities. What comes next? Like, what do I want to do next with it? Well, if this works, and if we can make this hardware properly work, and don't have to worry about bubbles and all of those dramatic issues, this could go further, and this could go whether that's in the future on the New Glenn or even further to the ISS, etc. This, those kind of things are certainly possible. Just as a, as the, I guess from a client view, I do have to also say that the process of becoming a client, as you mentioned, is really very, very nicely streamlined. And we did the approach you mentioned earlier, that we contacted you because we were applying to a NASA call, and had then been given kind of the support letter from Blue Origin that this was possible to fly our prototype. And so it's been really a great experience, and we're very much looking forward to flying this. So
I'm so glad to hear that. No, I think it's a really it's really interesting to see how
the personal note.
Yeah, it's really interesting to see how these things all come together, especially given the specialty needs of a field like the life sciences. We have a number of our payloads where things are coming out of laboratories that are super experienced with designing for spaceflight. And then we have a number of other clients that aren't as experienced and need more support. And they're partnering with groups like Space Tango to develop hardware or use hardware that's been developed for other applications, and really be able to focus on their science rather than on all the technology. I think Mayo is an interesting one sort of in the middle of that.
Right. And I think for us, it was, so we came to this kind of from a, more accidental route, like through a pitch competition that we won, and ultimately the real point of like really starting into this was, what can we do in suborbital flight in life sciences that really matters, right? Because it is a short flight, but there's so much value in this, and there's so much that we don't know of what the different gravitational changes and forces really do to cells, that this is really something we feel very strongly about investigating further. Enough about us, though. I do want to ask a few more questions. So in your pre-recorded movie, which again, I would urge everybody to go and watch afterwards, if you haven't already, you are also talking about the external payloads, and that's something that's, I guess, coming. And maybe we can talk a little bit about that, and what kind of, what sizes are possible, and if there's even an application there for life sciences, and what you would expect to be different there.
Yeah, this is one of those things that when we started flying our payload flights, we just sort of assumed that everyone would want to be inside the capsule. And then researchers started reaching out to us and saying, there's things that we need direct access to the spaceflight environment. And it was broad. It's not been monolithic at all. We've had folks coming because they want to deploy something that's going to come down through the upper atmosphere. We've had folks that have sensors that they want to mature, and they need that long path view up in space, or they need to be looking down at the ground and demonstrating something from above the atmosphere. We've had folks that are looking to sample, and what is, I think there's an interesting question of what's the sort of biology of the exosphere, and as we go up into the upper atmosphere, what kinds of things live there, what kinds of things survive through reentry temperatures. So that interface has been super popular. We actually flew it for the very first time on our last mission. That was a really fun payload, working together with NASA, looking at terrain relative navigation for the lunar surface. It turns out that when we were designing the Apollo missions, our landing ellipses were huge and really relied very much on an astronaut guiding us down to a safe landing. Now that we've got so much better capabilities at imaging and processing and autonomy, we think that we can really shrink up those landing ellipses. And there's no GPS on the lunar surface, but using LiDAR and imaging and processing, we can really do terrain relative navigation and touch down in a precise way. So we flew that payload on our last mission. We're looking forward to flying a whole lot more of these in the future. The primary real estate on the vehicle is up on top of the booster. It's sort of below the capsule. We call it the dance floor up on top there. The main interface is about the same size as one of our single lockers. So if you have those numbers there, you're same ballpark. And then we have the ability to cable out to sensors that are looking out or down as needed to sort of look at the rest of the environment around the vehicle.
That's very nice. Yeah. Where, like, apart from the human flight program with that, where else do you think specifically New Shepard is going to go going forward? What do you think is kind of the additional vision there?
So New Shepard is a platform for development. It's a platform for us to develop technologies. So really maturing that first stage landing system for use in our other New Glenn and Blue Moon platforms. It's a platform for us to test technologies. So on our last flight, we were testing new thermal protection system materials on the base heat shield of New Shepard for other applications. But it's also a platform for testing markets and growing markets. And that door to space has always been so closed. Even as we look now at space station opening up for commercial use, tickets to space station, depending on where you're buying them, are anywhere between $50 and $100 million. I don't know about you. That's not quite my couch cushions level.
Let me have a look.
Right. Yeah. But we think that the space should be for all of us. And so, our mini payloads start at less than the price of new American football uniforms for a school. Right? If you can have an athletic program, you can now have a space program at your school. Our payloads, are less than the price of an expensive piece of lab equipment or time on a world-class laboratory facility. And the human spaceflight experience will be so much more affordable than what you're looking at for a space station, that we're hoping that this opens doors that then let us grow those users and those use cases and those markets up to our other platforms.
Mm-hmm. And in terms of length of flight, is what we're currently seeing in terms of the 3 minutes of pure microgravity, is that what you believe is kind of the limit, but also what you want to retain with New Shepard, and then rather you use New Glenn for other aspects and for I guess then the orbital part of this?
Yeah, no, New Shepard was really designed to be a Kármán line vehicle to get you to the edge of space and back. And it's, in particular, if you can imagine, we could go higher with a lighter capsule, right? And the system is physically capable of that. At some point, your reentry velocities also get a lot higher, and that becomes something that the system wasn't designed to do. So I think for us, this is the profile for this rocket, and we'll have a lot of other things coming down that meet other market niches.
Mm-hmm. That makes sense. So maybe, if you don't mind, can we talk a little bit about New Glenn and what the plan there is, and again, what that could mean for life sciences and biological researchers and testing? Yeah.
So New Glenn is a Saturn V class orbital launch vehicle. It is very large, physically speaking. The first stage alone stands over 100 meters tall. It is designed to take tens of metric tons to low Earth orbit and large payloads to the lunar surface and elsewhere. So it really is designed to be that very capable, heavy lift infrastructure that opens up applications for a number of other things. Right now, I think what we're looking towards is that vehicle was architected from day one to someday be a human carrying vehicle. That's, as you mentioned at the beginning, Blue Origin is a company centered around this vision of millions of people living and working in space. So our vehicles are designed to start by flying payloads, move to flying people, but to have that in mind from day one, to have reusability and the ways that brings down the cost built in from day one. So I think is one of the best examples you see of that is our work with NASA on the Artemis program. We are leading a national team for the human landing system to take us back to the moon. Blue Origin, with our partners Lockheed Martin, Northrop Grumman, and Draper, developing an integrated system where our lunar cargo capability, our Blue Moon cargo lander, is supporting an ascent stage that has human capabilities from Lockheed Martin, being partnered with transit stages from Northrop Grumman, the guidance and navigation capabilities of Draper, and really coming together to offer this integrated solution that gets us back to the lunar surface, but this time to stay.
It sounds like a fantastic program. When those announcements were first made, I was like, that must be really incredible and really incredible to work on. And kind of, I mean, there's probably a lot of troubleshooting coming down there, but I'm sure it's a very, very exciting project. And I think you would agree that, you know, in terms of what this opens, you know, similar as you said before, right? The availability of space just becomes more, you know, like more likely, and there's more for anything in research. I mean, I know we're focused a lot of on the life sciences, but it's obviously not everything. There's a lot of material science and etc. that's very important, and physical sciences in general. And I think that, you know, having these kind of groundbreaking or this kind of groundbreaking forward momentum is really helpful, and I think for all of us makes it very hopeful. And the more that's flown, the, you know, easier it gets to hitch a ride on it. I thought maybe we can just briefly touch on how do so maybe for the audience. So I mentioned earlier that we got NASA funding to fly with you, and actually, as I can only reiterate this, you know, we got within the same grant 3 flights, so it is absolutely affordable, and the agencies are also very happy to fund this, and hopefully the Australian Space Agency will do the same in the future. Who do you get usually as your customers? Like, if you want to touch on that, like maybe what's their background in terms of, you know, how they're funded, and how much or which kind of, you know, grant funding, you know, are you usually seeing, so that people that are watching this can kind of go look into that as well.
Yeah, that's a great question. So I would say our customers fall into 4 major buckets right now. Science, and that's both microgravity and high altitude. Technology maturation, and we're seeing a lot more of that coming out of corporate technology centers, but also academic. Educational, so particularly for young kids all the way up through grad students that are looking to get that hands-on experience of working in space. And then things that are sort of more marketing, media, and entertainment. For the research and technology side, this is still majority a federally funded program. I think that is the domain that we're still in for spaceflight, that folks are coming in with grants from science agencies, grants from technology departments, but also increasingly we're seeing within the US, we have a small business innovative research program across all the federal agencies. A lot of SBIR companies seeing this as a pathway to maturing their tech for larger applications and markets. And then we're just starting to see that initial wedge of corporate investment directly. So internal R&D dollars that are going to catalyze a new program line or answer fundamental questions that makes the system possible. So I think that's all there. When we look at the international markets, those are also sort of across the board. We did three payloads with the German DLR space agency, and they were very much focused on fundamental science. On our last mission, we had 2 payloads coming out with Mu Space, which is a satellite development firm out of Thailand, very much on the technology and private funding side. So is a wide open space. I would say that where you're going to write applications for grants, it's always about what your customer needs, right? What the granting agency is looking for. In the US, most of the folks coming through the Flight Opportunities Program, it really is about technology maturation. We're increasingly working with the Science Mission Directorate to try to open up wedges of funding that use this more for the science value itself. But that for Flight Opportunities Program, it's showing that you have something that's working on the benchtop. You need more maturation in the spaceflight environment to open up the next steps. And so just sort of understanding what it is that your grant agency is looking for.
Yeah, no, that, and both of them make sense, right? It is, you know, if you can have that, you know, that more rapid step as you were describing this in a 6 months to a year rather than years to even longer, and you can get answers and make your changes, because most likely you're going to need some changes. In terms of international partners, in terms of international agencies, is there, I mean, bar whether they have their own restrictions, which I know sometimes happens, but for a customer to come in from, you know, a foreign university, for example, as long as their funding admits this, are there any bigger challenges for them to fly here from the US? I mean, let's not talk during COVID times, but like outside of that, maybe, as we're hopefully approaching vaccine effectiveness. But you know what I mean, that sometimes that can be challenging if you're not part of a country, or your institution may not be.
Yeah, so one of the things that we did early on in this program was we worked with the US State Department and Department of Commerce to make sure that everything that we do in this program as our standard offering was cleared for export. So our payload users guide can be distributed internationally. International customers can come on site at our facilities, work with our hardware, be present for the launches, get data from the flights, all those kinds of things. That's all that legwork has already been done. So hopefully that's made it easier. The only restriction we have is countries that can't do business with the US, so not much we can do there, but the vast majority of nations in the world, we're ready to do business.
Perfect. Oh, that's really awesome. As we're approaching the last minutes here, if anybody in the audience still has questions, please don't hesitate to put them into the Q&A box. I guess in terms of maybe if we dream a little bit bigger and also go to the moon and maybe beyond, like, is there something else that you would want to share where you know, what Blue Origin would like to do? And you say, well, we want to create, you know, people living in space and working in space, but is there a specific focus area or something where you say, this is going to be our strength, we're going to be, you know, the engineers that do this, or, you know, something specific that is kind of in the future there?
You'll hear a lot of programs talk about destinations. For us, it's not about destinations, it's about infrastructure. And one of the things that Jeff Bezos repeats that I really sort of take to heart is that when you look at Amazon, he built that as an entrepreneur on a base that was already existing. We already had interstate commerce and the internet and credit cards and you know, shipping capabilities and all of these things, so that he could come on that base layer and just overlay an application that then took off and serves so many of us so well. I think we are looking to be that infrastructure layer in space, and that's why you see us focused on transportation, cargo delivery, infrastructure. It's really about being the enablers for everybody else's visions. And so there's a little bit of, if you build it, they will come in that, but we're trying to make sure that as we develop that infrastructure, we're also, you know, building the ecosystems and the communities around it, so that our users understand the opportunities and can come join us and really take advantage of it and build together. A future of millions of people living and working in space for the benefit of Earth does not happen overnight. So the other piece that we're really focused on right now, you'll hear us talking about our Club for the Future. This is our educational nonprofit for getting the next generation excited about what's going on. We know that this is a vision that takes more than one lifetime. So really thinking a lot as well about how do we build inspiration that allows kids to see themselves in this world. And so for those of you who have kids in your world of any age, or if you view yourself as a kid, do check out clubforfuture.org. We have a program right now where kids of any age can draw their vision of the future on a postcard, send it to us, we'll fly it to space, bring it back down, mark it as space mail, and send it home. I don't know about y'all, but I remember the first time I got a piece of airmail from my grandparents when they were traveling internationally. And that just like, it was the most incredible thing to open my mailbox and see this thing that had flown over the ocean. And so for kids to have something of theirs that has been to space and comes back and is now, you know, in their hands, I think is tangible. It lets them see themselves as being part of this journey. So appreciate that we have the opportunity to help do some of that inspiration.
Yeah, I do have to admit, I don't think I'm enough of an adult to not do this either. I think it's incredible, and I think it's a fantastic opportunity. And I for one, am certainly sharing this with all of my friends that to encourage their kids. And I think it's a really incredible opportunity. I gotten another question through an email in, and it's maybe more something to kind of reiterate on. The question was, what's the timeline from launch to recovery for the actual biological samples in this case? If it's something that needs to be, you know, more or less urgently recovered, what could be kind of an expected timeline?
Yeah, so launch to landing is about 11 minutes. And then from the time we land till the time we can have samples in your hand is less than an hour. So we did this on our last mission. We had a university that was doing genomic sequencing of samples, and they really wanted to get out there and rapidly fix them. And they had samples in their hands, I think it was like 40 minutes after touchdown. So really trying to be responsive to that timeline for biology.
That's very fantastic, yeah. And just maybe we could go, and I know you touched on this a little bit when we were looking at the locker systems and all that, but what kind of data and flight data is available, and how does that integrate, or can that integrate with the system? If we want to just briefly touch on that before.
Sure. So for each of our locker systems, and also for the mini payloads, we have a feed over Ethernet or other USB, for instance, in the minis, that carries with it a lot of data from the vehicle. So it'll tell you your mission elapsed time, your altitude, your sort of gross G levels, your rates of rotation, the phase of flight that we are in, whether the parachutes have come out or not. And I would say the majority of our users take pieces of that signal and use it to drive their hardware. So you might imagine when we get into the coast phase and we're in stable microgravity, then you might want to turn on your pumps. Or when you get to getting ready for re-entry, you might want to introduce your fixative into your sample, those kinds of triggered events. So that's available standard on all the payloads.
That's very perfect. And from a personal point of view, also something that will be really crucial for us, both to integrate, but also to really have that proper time-stamped kind of manifest. I think if there are no other questions, I would, probably wrap this up here. If unless there's something else you would want to share with us, Erika, you're obviously welcome to do so.
No, I would just say we're just excited to work with researchers. There really is something about making this vehicle deliver real value back to the users that makes my day. And so we're excited to work with you. I hope you'll reach out if you have an idea or a question about how to use the platform. Again, it's just payloads@blueorigin.com. Feel free to send me an email. And as we move into this era of human spaceflight, I hope some of you will get a chance to come and fly with us and go above the Kármán line and earn your astronaut wings in the pursuit of your science as well. So really exciting times ahead.
Absolutely. I mean, I'm like getting goosebumps just thinking about it, and I don't think I can't wait until these future calls in the grants have that line crossed out that says it doesn't include the researchers to fly. So that's going to be an exciting time when that's going to come, and I'm probably going to sign up for it as soon as that is possible. So thank you very much for making the time today and for sharing all the capabilities that Blue Origin has and is developing. It's really exciting, not just from a personal standpoint as somebody who's going to come fly, but I can only reiterate that the workflow and the way to get engaged with Blue Origin is really simple. They're very responsive, and I can also encourage everybody to contact Blue Origin for their flying needs. And with that, thank you, Erika, for your time and for sharing all of this with us. And thank you to everybody in the audience, either live or in the recording in the future. And with that, I'm going to conclude our last live event of our symposium this year. And please go check out the YouTube channel. There's still more to come. Everything is going to be uploaded. It may take a day with all the time zone differences, but this is going to stay. Most of the talks are going to stay as long as we can maintain the channel. And I think we have some really, really amazing speakers, and today just added to that. So thank you, Erika, and thanks everyone.
Thank you, Chris.
Okay, bye.